Alright, one of the first things that we're going to look at is electrochemistry. So electrochemistry is still what we did last year, so it's the movement of electrons from one place to another. So there's two things that we need to think about here. So we've got the electro part and we have the chemistry part. So electro is obviously looking at electricity, and what do we need for electricity? I drilled it into you last year that we need free moving charged particles. So that is the most important thing. And in redox, what's the thing that's moving from one species to another? Oh my goodness, it could be electrons. So because we've got electrons moving, we now have voltage and we have electricity. So that's the electro part, and then the chemistry is our oxidation and our reduction. So here I've put in a really cool video, and he's kind of cringy to watch, and to be honest, he has like this weird smile thing going on, but he's actually very good at explaining what's happening with electrochemical cells. He's probably actually better at explaining it than I am trying to use this slideshow, so highly recommend that you actually watch him because he'll be able to explain it really well to you. Alright, so electrochemical cells. Again, essentially last year what we were doing is we were doing a whole lot of redox on paper, whereas this year you can actually do it more in practical. So if you imagine you have got two beakers sitting in front of you, okay, they have got separate reactions in them, and we would call them half cells. So that's like your half equations. Alright, so a half cell is made up of a metal rod, so that can be any type of metal, zinc, copper, and it just needs to be in a solution of iron. So it could be zinc ions or copper ions or some other sort of thing. So we call the metal rod the electrode. So the electrode can be made out of inert metals as well. So inert meaning that these metals don't actually react with the solution. So that could be things like platinum or nickel. Platinum is probably the more common one that we would use in year 13. Okay. So in one half cell you will have the oxidation half, and then in the other half cell you will have the reduction half. Okay. So in this example down the bottom here, okay, you've got a zinc metal in a solution of zinc 2+ and nitrate, and on the other side you've got a copper metal with copper 2+, okay, and you've also got nitrate in there as well. See how these two beakers are not actually connected together in any way? Yep, so at the moment they're just going to be sitting there, they're not actually doing anything, they don't react with each other because they need to be connected to each other by what we call a salt bridge. So that would be this thing here. Okay, so an electrochemical cell is made by connecting two half cells. So in here, on one side we've got an anode, and then the other side we've got a cathode. We'll go into that a little bit later. Okay, but essentially this is what your standard cell is going to look like. So you have to have one thing that's going to oxidize and one thing that's going to reduce. If they're both oxidizing or both reducing, they may not work together just like last year. Okay? And because you've got redox occurring in this cell here, you have your electrons flowing from one side to the other. So essentially it's creating electricity. Another word for this is actually just a battery.